Hi, it's Joe Como here from the UBC Providence Healthcare Research Institute for Heart and Lung Research. Along with me is Sean Rickard.
And my name is Sean Rickard from SUSE.
And we'll be talking about increasing SUSE Enterprise Storage performance for iSCSI and hypervisors, specifically VMware. And we'll talk a little bit about who we are.
So one of the great things about working with the Providence Healthcare is not only are they a wonderful technical partner of SUSE's, but they're also an icon in Canadian research in medicine and cancer research. They are the leaders in heart and lung disease. They are directed by Dr. Don Shin, who is a world leader in chronic obstructive pulmonary disease. And they've been founded by two members of the Orders of Canada, two recipients of the Order of Canada, Dr. Jim Hogg and Dr. Bruce McCannis. Dr. Jim Hogg is actually a very interesting and inspiring man. At 84 years old, he is still coming into work every single day. So this is a man that loves what he does and sees the importance of the research that is done at the Heart and Lung Research Center. So Providence Healthcare Research Institute of Vancouver, BC has a couple of locations. The location where our deployment is stationed at right now is at the St. Paul's Hospital, which was built in 1894, and the research center was actually opened by Dr. Hogg in 1976. Now, not too far from the St. Paul's Hospital is the largest research component of Providence Healthcare, which is the University of British Columbia campus that's situated in Kitsilano, just about 10 kilometers south of St. Paul's Hospital. Wonderful school with a great campus, and it is actually seen as one of the best medical schools in the entire country. So that being said, I'm going to pass it along to the man, the myth, the legend, the brain behind the installation, the wonderful Joe Como.
Thank you. So why did we pick SUSE Enterprise Storage? About 4 years ago, we were doing lots of research. We came across, at that time, SUSE Enterprise Storage version 2, and found it fairly interesting. And then we found some articles about Yahoo and what they were doing with Ceph. And we didn't have the requirements to have the throughput that Yahoo did, but we were storing lots of large data sets, micro CTs, digital slides, gene sequencing, confocal microscope, and we're getting a brand new specialized MRI this year. It's been slowed down because of the environment we're in right now, but the acquisition that is. But all these are large data sets that we need to be able to continue to store the data for. And we've seen a minimum 25% growth year over year with projects. Now, we've had many storage arrays and upgraded through the history. The problem with the storage arrays is even when you're buying from one vendor, you have models that you're limited to, and have to, in order to exceed that limitation of that array, you have to upgrade to the next array. And that is fine when you're at 100 terabytes, but when you start to get too big, it becomes too difficult to continually move. So that's why we wanted to look for something different, more affordable, easier to manage. What we'd hoped would happen was we'd be able to throw everything at SUSE Enterprise Storage, VMware block, Microsoft and Oracle databases, applications, network file shares. And for the most part, it could do almost everything except for our demanding database work. So we'll talk about some of the hardware choices we made at the time. We have a great working relationship here in Canada and the West Coast with Dell, and they're great people to work with too. So we ended up buying Dell servers, some Dell Force 10 switches. We worked with Intel, again, going back to the article with Yahoo and Ceph, and we also installed a product called, at that time was Intel Cache. It's now been converted over to openATTIC, and it's a free product from Intel that improves performance for both Linux and Windows if you're using Intel hardware. So this is a look at our servers here. This is a 24 hard drives in one server. Actually, it's 12 hard drives in a server and an additional 12 hard drives in an expansion tray. And that's our OSD server components. Up at the top of the rack here, you can see our monitor nodes, our network switches, and our iSCSI gateways.
Now you guys are a spinning disk installation, aren't you?
That's correct. As much as we'd like to go for performance, we had to go deep to be able to store the data sets. Our workflows, we usually acquire the data. Sometimes we don't even analyze it right away, but at some point in time, it needs to be analyzed. And since it's fairly expensive to get research data, you want to keep that and store that forever. So we want to be able to reuse that data over and over. So that's why we went for the hard disk or the less expensive storage model. This is just our brief network. It's pretty standard for Ceph and SES. So these are some of the benefits we looked at. So the cost for acquisition was quite a bit less. I'll say approximately 30% less than the storage array. Maintenance was substantially less because you're not locked into the typical storage array component for maintenance. We could easily expand, and we've done so over the years already. Performance compared to our previous array was up. Capacity was up. And again, compared to our previous arrays that we had in place, our latency was down. And we'll talk about that next year. So SUSE helped us get this going in testing and installation. And basic performances, we did some network and disk tests. We can see we get a 25 gig per second performance boost for a single thread. When we flooded the network with 10 streams, we got close to our 40 gig network that we have in place. Here we have a 200 meg continuous write for hard disks and a 1400 meg write for the NVMEs. We did a lot of other server tuning according to what SUSE specs. We did some performance testing with Fio on virtual machines, both on the new array and on our old arrays to do some comparison. Down here is the Fio command we use, so you can take that if you wish to try to test your system compared to ours. And this is what we got. Again, our current array at the time was 4 years ago, and the array was much older than that, so I'm going to say the array was probably 8 years old, 7 years old at the time. This is running with SES and Intel CAS, which is now called OpenCAS. You can see the bandwidth we were getting much greater. IOPS were much higher, mostly due to the Intel NVMEs. Latency was down for this was specifically 4K random writes is what we were targeting, because at the time Ceph was having problems with lots of small writes. So 4K was the optimal test for us. Latency was a 99.95% latency is what we're looking at, and again that was down substantially compared to our old array. Our old array was a fiber channel array, a 4 gig fiber channel array, so you know. So if we look here on the left, we compare to our old array and SES4 at the time with Intel OpenCAS. So we can see a huge improvement across all bandwidth, IOPS, average latency, and also the tail latency. And then over here we're comparing just SES by itself versus SES plus Intel CAS. And again, we can see for 4K random writes, huge improvements when using Intel OpenCAS. So along the way, we've had some growing pains. We'll talk about them. Sean will remember in the early days of SES version 3, we had a problem. Monday mornings, for whatever reason, it would kick off every Monday morning. Our servers would start to crash. And that was because at the time, our OS for the OSDs were SSDs. We had NVMEs in the server plus all the hard drives. The operating system wanted to trim not only the SSDs, the NVMEs, but it wanted to try to trim all the hard drives. And it kept crashing our servers, but it would take our servers off randomly, independently, in different orders every week. And this was solved simply by upgrading to SES4, and that the underlying operating system upgraded in SES, and everything was wonderful after that. When we implemented SES4, we implemented encryption run across the array. Great feature, lots of new additions in there. But the problem with encryption was, including Intel OpenCAS, was it required a 45-minute boot per server. So every server was 45 minutes in the disk storage pool. So for us, to reboot the OSDs, it was over a day, and we had to do it manually because of this issue. So this persisted with us for SES4, SES5, finally SES6 alleviated this issue. So moving to SES6, we had reservations because it's always a little interesting when we do an upgrade. Everything went fine with the Salt Manager. The first monitor was great. As soon as the second monitor came in, the quorum changed, unfortunately. And as you can see here, I wanted to scrub and deep scrub all our OSDs, even though they were clean before the upgrade. This was because the setting for scrubbing had moved in the Ceph comp file. It was under OSD before, and it had moved to general. Whether that was a configuration on our part or a Ceph config change, I'm not sure, but that was what was causing that problem. So we had to disable scrubbing and do a lot of work there. Also, with the encrypted volumes, the way it was set up originally was we had a wall partition, a DB to partition, a data partition, and of course the encryption key partition itself. So there's 4 partitions per disk. When we did the upgrade, we had to go through 96 councils, 4 partitions per disk, 24 disks. It took us forever to do the upgrade again per server. The benefit behind this, however, now, our servers now boot in 4 minutes. Down from
So that's not bad. Going down from 45 minutes to 4 minutes, and all you had to do was get carpal tunnel syndrome.
It's a huge benefit because now, before, for us to realistically patch the cluster, it would take us half a week or so. Now we can patch the cluster in 2 or 3 hours. Fantastic. Moving again from SES5 to SES6, upstream in the Ceph community, they decided to change the password constraints on the iSCSI portals, gateways. And so we ran into a problem where our old password was too short and didn't meet the requirements. So we had to get SUSE engineering in, who was fantastic through this whole process. They helped us on multiple different scenarios, including the previous encryption, getting past the 96 councils per server and lots of other things we had to do. Anyway, the chat password requirements were changed, and they helped us along with that as well. So after we upgraded to 6, we then had to do the migration to LVM. And we had to move the data off or distribute the data from each of the OSD nodes, and that takes about 2 days. And then during that, even though we were well below the 75% or 70% data requirements to do this, Ceph doesn't do a very good job of distributing data, whether you're writing or removing it. So we rebalanced multiple times during the evacuation part of the data. And then we quickly blanked the disks and the NVMEs and redeployed the server. And then we rebalanced the cluster. We're bringing it back in. Again, it took about 2 days. So each server OSD node took about approximately 5 days to do this for each of the OSD nodes. And we're now on LVM, very happy. Everything seems to be running very smooth now. So running SES optimally. Again, I'll talk about Balancer. This is a wonderful tool. You can see up here that SES doesn't do a good job of balancing. Some of the disks OSDs here I showed have 70% or so. After running Balancer down here, right across the whole array, it's at 60, 61%. And we typically run Balancer once a month or sometimes every 2 or 3 weeks, and it redistributes the data. And usually we run it a couple times consecutively. The only thing to be aware of when you first kick it off, it does put a huge load trying to redistribute the data right away. So you don't want to do it in the middle of the day. Scrubbing. A huge problem we had with scrubbing. everybody wants to have scrubbing outside of normal working hours. The problem with that is the biggest task that we have, or I'm sure most people have, is backup, which really slams your systems. And you can see here, during scrubbing, when it's set in Ceph Comp, we have a decrease in performance during backup windows when the scrubbing window is also in place. Normal working hours, we've got normal performance. And these are our settings right now for a scrub that's in Ceph Comp. We scrub every 2 to 6 weeks for the regular scrub, and deep scrubs we do minimum 1 every 8 weeks. So what I did is come up with a custom scrub and deep scrub interval. And so we do from 7 a.m. to 7 p.m. or 1900 hours, we do 2 scrubs every 5 minutes and 1 deep scrub every 20 minutes. Nightly and weekends, we do 2 scrubs and 1 deep scrub every 5 minutes. And what we do is we go and we pick the oldest OSD that hasn't been scrubbed, whatever, and we scrub that. So that way we're always within the window. Usually for scrubs, we're every, right now if you go look at a stats window, we're usually just over a week that they haven't been scrubbed. And deep scrubs are, I can't remember, but I'm going to say about 4 weeks. So we're much faster than the Ceph Comp. When it goes to 7 p.m., the Ceph Comp still kicks off scrubbing, and Ceph still wants to do scrubbing, but once it's realized everything meets its requirements, it backs off. So there's only a very short window where it attempts to do scrubbing at 7 o'clock.
Has your client end user really seen any performance drop by doing a scrub that quickly?
No, actually, because it's sort of our normal practice to do scrubbing and deep scrubbing throughout the day. All our applications now, you never notice it. Users don't notice it. Backup is on par now. Backup doesn't notice scrubbing at all, and so it's an improved right across the whole cluster as far as performance goes. And here what I'm showing is this is deep scrub here, but this is balanced out how we deep scrub per day, and this is balanced out how we do deep scrub per hour. You can see that where my script kicks off, it's in the evening it increases, and during the day it's a little bit less, but the users don't see a performance hit at all with scrubbing now. So Intel CAS, or they now call it OpenCAS, is installed on all servers, and what we do is we have a 1.8 terabyte NVMe. Actually, we have 2 of them. The first one does the first 12 OSD disks. The second NVMe does the balance of 13 to 24 disks. And we have, for the wall DB, we have a 48 gig partition where they both sit now. The balance of each of the NVMEs is for OpenCAS from Intel, and it does caching. We run it in write-back mode, and we run it in a special mode that Intel helped develop with us and some other people to evacuate the cache to disk as soon as possible. That way, when we want to unload the caching, it doesn't take very long. The original method would require 6 or 7 hours to unload cache, and that just wasn't practical for us when we wanted to do maintenance. Another piece of software that we've added along the way to help kick up performance is VirtuCache. And again, this runs with an Intel NVMe, but we run that inside of our VMware hosts. And again, this is for caching for users and for the VM servers. Again, it is a huge improvement. Again, we're running it in write-back mode. And when we're actually accessing the data on a consistent basis, you would never know that it's running off of a slower SES infrastructure, all disk. So we'll talk about our VMware config a little bit. So we have 3 hosts, 378 gigs of RAM, 24 cores times 2, 40 gig NIC, and again, like I mentioned, the 1.6 terabyte, I think it's actually 1.8 terabyte NVMe. Veeam backup software we run on top of this. We're also running Windows 2019 server resilient file systems. Huge benefit when you're using Veeam. VirtuCache in each of the hosts. vCenter is 6.7. So we have 2 iSCSI portals. We have 1 large pool with 4 RBD images. We've adopted SUSE's TIDs for both VMware and for Veeam environments. And we've also done a little bit of CPU tweaking, and we've implemented round robin on the both the iSCSI and the VMware side for iSCSI connectivity. We have more than 200 VMs, mostly Windows 2019 or SUSE servers. We have a few appliances. Other than that, it's pretty well our mainstay. We have a local backup repository on the SES system as well. And we do remote backups to Kamloops, which is about 200 miles, 350 kilometers away from us, up the interior, out of the earthquake zone. So Windows servers on the SES system are our backup repositories, and we're using ReFS again on 2019. Its major feature is something called block cloning. Allows us to maintain 4 full weeks of backup in just 1 week's worth of already deduped and compressed backup space. So huge savings for us. Here we show before a backup, we're using about just less than a terabyte or about a terabyte. I chose this so you could see that difference. During a backup here, it really doesn't show much of a difference, but it is increasing the actual use space here. And post backup, we see that it's down minimally, not the 1 terabyte that it would be if you were using an additional 1 terabyte of storage, but because of block cloning, it's only down fractionally, about 20%. So huge savings to storage there for us.
And all these are being served by SUSE Enterprise Storage, correct?
Everything here is running off of SUSE Enterprise Storage. Yes. Backup, all file systems, all storage, all image analysis. The only thing that we don't run off of SUSE is we have some high performance requirements for some Oracle servers. But that's it. And even that, we play around with it every once in a while in SUSE Enterprise Storage. So here we can see our performance that when we're doing a backup. I had a better slide, but I never got it in time. But getting about 576 megs per second across the cluster when we're doing backups in Veeam. And this is the openATTIC view. Again, before we upgraded. We just upgraded to SES 6 in case anybody's interested. We did that just prior to the COVID outbreak and during the COVID outbreak. So as you can see here, we're getting 900 megs across the cluster. Usually this is when we're doing backups, and this is the IOPS that we're getting through for backup right there. So a word of warning for anybody who wants to think about this. VMware changed the behavior of VMware 6.7, but they didn't tell anybody. So it caused us huge problems, and it's basically because SUSE Enterprise Storage changed the iSCSI portals, and we were aware of that, but we weren't aware of the ramifications of both the interactions of the iSCSI portals, gateways, with VMware and round robin. So what ended up happening previous to the upgrade was we could patch one of the iSCSI gateways, reboot it. Immediately once it was up, we would patch the other one and reboot it, and we'd be, have both gateways patched up in 5 minutes. Nowadays, unfortunately, we have to patch, reboot a gateway, wait for round robin to take place in the new VMware kernel, which takes at least 5 minutes by itself. Then we do another patch on the second gateway. Because of this issue and history and knowledge and experience of the previous configuration of both SES and VMware, we took our cluster down multiple times because of patching the iSCSI gateways without realizing the issue. VMware has since rescinded their change, and it's listed here. And so there's another patch which rescinds how VMware 6.7 works. So it's a good thing to be aware of. Our future plans. So I got this in quickly. This is the SES dashboard. The reason it's warning is because I think I got scrubbing disabled here while I was updating my scripts, because the scripts were different between SES 5 and SES 6, so I had to update them. This shows you our movement. It's pretty interesting. This is a network view. This is our typical workload. We up and down all the time as backup, and everything else kicks off. So then this is here when we were starting the upgrade process to SES 6, and we ran into some problems. You can see almost no work because we weren't running backup. We weren't doing anything. Users were still hitting it, so the user load is quite low compared to backup here. And then this large section here is when we're evacuating data off an OSD. This small section where we're actually upgrading the OSD server and then redeploying the data back to the server. You can see the huge workloads here.
It's pretty impressive that with the amount of data that you guys are using, it still only took 2 days to get everything done, because that is a really impressive amount of data that you're dealing with.
That's 2 days per OSD node, so it took us about 30 days to do the whole upgrade of the cluster from SES 5 to SES 6. But yeah, that's because we're being safe. Back in the early days, we used to do silly things like just drop a server and redeploy it because we didn't have much data, and we weren't in production yet. Once we're in production, then you have to be safe and evacuate your data so that you have 3 copies across your entire SES cluster. So what we plan to do, we have some new EPIC servers in. We have some AMD version 2 EPIC Rome servers. We're looking at using some of these with maybe some U2 NVMEs, maybe bring them into SES if we can get some to test with. We're looking at adding a third iSCSI gateway, more OSD servers. We're looking at trying to get some of our system online for CEPH-FS. We just don't have enough storage space right now because we're almost full. We're at the 75% mark, so we're trying to get some more ordered during this difficult time. And also too, we're very interested in the Windows for Ceph environment that is. We'll be coming out with SES version 7, SUSE Enterprise 7, I believe. And so that's the end of our talk.
Hey, Joe, I absolutely adore the fact that, all the really important work that you guys are doing over at Providence Healthcare is actually being saved on SUSE Enterprise Storage. And, and thank you to you. The work that you've done, with us, with our engineer, sharing the hiccups that you come into, it helps us build a better product. So thank you so much for sharing all of this.
Oh, and SUSE Enterprise Storage, Boyd, my mom, is fantastic. I'm dealing with him a lot, and he's really great. So it's been a pleasure working with you guys.